You're given an integer array height of length n. There are n vertical lines drawn such that two endpoints of the line are I0 and I height. Find the two lines that together with x-axis form a container such that the container contains the most water. Return the maximum amount of water a container can store. Okay, so basically you have lines here. So this is an array representing lines, right? And you have to find the area like this to find the most like a square where you can put the water in. So in this case you have 8 and this is of the width of 7. So 7 times 7 is 49. So you return 49 here. So we could probably do like a mapping here. Okay, just 1, 2, 3, 4, 5, 6, 7, 8. Okay, then you have the first one is 1, 8. So you have 1 and then you have 8, then 6 is here, 6, 2, 5, 4, 2, 1, 2, 3, 4, 5, 5, 4, 8, 3, 7. For just 8, 3, and 7, something like this. Okay, just extending the line here. Right. So the biggest area is this part here. Like let me change the color here to make it red. This part and this part. This is the area that is the biggest one. Back to back. Okay. So this one returns it's 8. This is 7 actually. 7. It's 8, and then you have 7 here. So 7 times 7 equals 49. So that's how you got the maximum area. So why not this point here? This is 1, 2, 3, 4, 5, 6, 7. 7 times this is 7 and 2, which is 5. To basically subtract 7, the distances, this is 5. So 5 times 7, which is this, is only 35. So you basically still have 49 is the highest, so max. So whenever you hear a max, maximum or minimal, probably usually this is a greedy algorithm, and obviously the most common, most practical way to solve this is you just basically go for each of the index of the array and then multiply. So you start with 1, multiply this from all the length and the height, right? And that will give you a 2 formula, which is n squared, which is not the most optimal one. So there's another better approach to solve this, that is using a 2-pointer. So you can, if you notice, like you're basically just need the bar between this and this, right? So you need the minimum left bar and the right bar, and then you could calculate the distance between the two. So in that sense, you could technically have a pointer which is from the left and a pointer to the right, which is this. So LNR. And then you try to squeeze the pointer. Squeeze the left, you squeeze the right, while you're calculating the maximum area. So when do you squeeze left and right is the question. So if you notice here, if the right is greater than the left, so initially the left is the zero node, right? So yeah, 0 I 2 4 5 6 7 8. So start with 0, and the right is on the 8 position. If this side is bigger than this side, you move the left, increase the left. So basically you're moving the pointer of the left, try to squeeze, and then you calculate again the area. Now in this case, this one is bigger than this, so now you move the right, squeezing it on this left. So this one is gonna move here on the second. Eventually they will squeeze out until you don't want the L somewhere like squeezing left and right. So in this case, your left should be less than the right, right? And then you exit out of the loop once they pass through. Yeah. So that's how you basically solve this problem optimally, and that will give you a better solution, which is an N, rather than the first one we just read solution, just force it out. So yeah, I think we should try that and see how far we could go with this. So you have a left, right, which is as mentioned, which is 0, and then you have the right, which is pointing to basically the height of the length of the height minus 1, and then you need the max result, which is initially just assign it to 0. So your while L is less than R, do the volume. So we need to calculate the area, the water, which is you can consider it's area, and the area is actually basically you find the minimum between left and right. Cement is height, I, height, J. So this is your x-axis. Then you multiply it by the y. This is your y-axis multiplied by the y, which is J minus I. Right? J minus I, which means initially is 8 and 0. So 8 minus 0 is this is 8, and then this is your height is, you're trying to find the minimum here, so you're basically trying to get 1, because that is the square. The minimum is the square. You don't want to get the max, because the max it won't form a square, because this one is smaller. So rectangle. So basically you have to find the minimum, right? And then if area is like greater than the max, so you basically assign the max to the area, and then where you put the height of I is less than height of J, so you basically move I, and else you squeeze them, J minus 1. So this is more like a two-pointer solution. Return max, and you need a mean function. Golang doesn't have a mean for int. It does have minimum for it has a minimum for float. So but in this case we're using integer, so you cannot you want to cast it, but I don't think it's necessary. So then return D. That's it, your solution. Try it out, see if it's gonna work. So we have some syntax error. Okay, there's no while. So for okay, I and J. Okay, yeah, so we can just replace it with I and J, or L and R. Okay, there you go. So this is like a two-pointer solution where you squeeze the pointer until you get the left and right, until you get the corresponding correct area. Yeah. Okay, so that's it. It's a pretty quick one. If you like the video, hit like and subscribe, and see you on the next episode. Thank you for watching.